everyone, welcome back. This is Engineer Hussein Wasapi. Alright, so we're still looking at the vector addition in 2D using the parallelogram law. Alright, so before we begin, don't forget to like and subscribe. Alright, so the next objective, which is objective 2, is learning how to find the magnitude of the component or sometimes even the resultant or both, given information about the resultant and the other component. Alright, so basically this is just how we go about finding the component or even the magnitude given to, because if you recall from the previous video, hope you watched. If you didn't, you can always go back to the playlist and look for the video which had objective 1, finding the resultant given to vectors. So in this case, we're trying to find the magnitude of the components or one of the component or even the resultant or both, given information about the resultant, which means that it could be information where I would tell you to say the resultant is acting along the positive x, which means it's maybe just in the x, or the positive y, just acting in the y, or negative y or negative x, and some information about one of the components. Alright, let's get to it. So we understand this with an example. Okay, let's look at the example that we have. The example says determine the magnitude of the component force F, this guy here, and the magnitude of the resultant Fr. So we also have to find the magnitude of Fr. But there's more information given. We've been told that if Fr is directed along the positive y-axis. Now, what does it mean when they say directed along the positive y-axis? This simply means that the resultant force is acting along the positive y-axis. So, if I draw the resultant line along the positive y-axis, I call this F sub r, since the vectors I'm having are force vectors and the units are in pounds. Pounds are just some other units we use for weights. Don't let them get you confused. Yeah. So we have the 200 pounds there. We also have the 30 degrees there and the 45 degrees there, and the F we're looking for, as well as the resultant we've just found right now. Okay, so now, how do we go about solving this? So we've been given some information about the resultant and some information about the missing component. We know that we have that 45 there. So now, if you remember from the steps, remember step 1, what are we supposed to do? We're supposed to extend the what? The lines. So let's extend the lines of the components that we have. If we want, you can even extend the resultant line. So if we extend the component line, extend it like that. So extend this guy here like that. Even the component, if we want, you can extend it like that. Then all we have to do is to draw parallel lines. So I'll draw a parallel line of the 200 pounds that will pass through F. So I can draw it here, I can draw it anywhere. I can draw it anywhere, provided I'm comfortable with it. So I'll draw it here. Now, this is the trick. Remember that whenever we draw the resultant line, it comes from the center. But in this case, we have already drawn the resultant line here. So which means that as we are drawing the parallel lines, we have to make sure that it touches the resultant line at the same point. So the parallel line of this line, which is parallel to that line, should touch this point where it has touched. And then the parallel line of F, which is this line here, should touch the resultant point, that point there. Because if you draw it there, it means that you won't have a clear image. As you are even computing, you'd end up making some mistakes. So remember that you should always join the resultant point. So I'll draw it like that. Remember, we end up having a quadrilateral like that. And after that, we have to now draw the resultant line. Now, we've already drawn the resultant line. It's already there, so there's no need of us doing that. So, what we can do is now find the angle in between the two vectors. Now, we know that this portion here is what? 45. All I need to find is this missing portion here, so that I can sum up this 45 plus whatever I will have here. So what we'll do is that I will find theta here. Now this point to that point forms a 90 degrees. So theta, this point will be theta, compute it somewhere there. Sorry about that. Okay, let me just get my eraser properly, reduce it, and then until eliminate that, then I can go back to my beautiful pen. Okay, so I'll just draw it, compute it here. So theta plus 30 should give me 90. So theta is equal to 90 minus 30. So theta is equal to 90 minus 30, that is 60 degrees, which means that theta is 60 degrees. So the angle in between here will simply be 45 plus 60, which will give us about 105 degrees. So this angle here is simply 105 degrees. Now that we have found the angle, we can simply draw the quadrilateral so that we can see the clear image or the clear view. We can draw it in any way we want. So I'll draw it like that. You can draw it in any style, provided that it's clear for computation. Alright, so let me define this as my center, which is that point there. So I know that the angle in between the angle there that I have found is 105. So the angle here is simply 105, which means that even this is what? 105. So we know that this line is parallel to that line, and this line is simply the F line. So this is F. Even this is what? F. This line as well is parallel to that line, and this line is simply equivalent to the 200 pounds. So we write 200 there, 200 there. It's basically as though we're using the procedure we're applying when finding the resultant given two vectors, because we're doing the same thing. We're extending the lines, drawing parallel lines, looking for the angle in between. After that, look for all the possible angles, then draw the resultant line, pick one triangle, find FR, just like that. So what we'll do next is simply find the missing angles. So this is X, and that is also what? X. So I know this is a quadrilateral, and it adds up to what? 360 degrees. So I'll say X plus 105 plus 105 is equal to 360 degrees. 360 degrees. So this will be 2x plus 105 plus 105, that should be, if I'm not mistaken, that should be 210. So it will be 210 being equal to 360 degrees. So 2x is equal to 360 minus 210. So 2x is equal to 360 minus 210, that is about 150. Divided by 2, x is equal to 150 divided by 2, that is 75 degrees. So this means we have 75 degrees there, and we also have 75 degrees there. So I found all the missing angles. Then the next thing we're supposed to do is to draw the resultant line from the center touching our point of interest. The point of interest is this point there. So we'll draw our resultant line. So the resultant line is simply cutting 105, so which means 105 will not be considered in any way. So this is our force resultant, as you can see. Alright, so now after we do that, all we have to do is now analyze the drawing that we have. Excuse. Alright, so if we analyze the drawing, you'd find that even if I had to pick, because this is shape A and shape B, even if I had to pick shape A or shape B, I won't have enough information to solve, because I know this is 75. So two sides and an angle at the middle, I can't apply the cosine, isn't it? Even this side, because it's the same thing. So now, what I'm supposed to do now is to go back to my drawing. So in our drawing, let me just clean it up a bit like that. And not that. We're having this like that. This is our resultant our resultant line. We found this angle to be what? 60 degrees. So we have angles that can help us to determine the sides that we want to find. For instance, we have the angle there, which is what? 45 degrees. And we also have the angle there, which is what? 60 degrees. So if I pick A or B, I will end up finding one of the missing what? Sides. So I'll start with A. So if I pick shape A, we're having something like this. So this is 75. This is 45. And we know that this is F. This is force resultant. And this is what? 200. So either picking shape A or shape B will give you all the information you need. So now I'm having two angles. Now remember, this is simply a triangle. And the interior angles of the triangle will add up to what? 180 degrees. Therefore, I can find the angle here, X. So if I find that angle, it means my computation will say X plus 75 plus 45 should give me what? 180 degrees. So X plus 75 plus 45 will simply give you, if you compute that, 75 plus 45, it will give you 120 degrees. And this will equal to what? 180. So if you solve for X, this will be 180 minus 120. So X is equal to 180 minus 120, which will simply be 60 degrees. This simply means that what you have here is 60 degrees. Now, this information for this structure has already given us what we need. So I'll just erase it. I'll get my beautiful rubber, my wonderful eraser. I'll increase the capacity like that. Okay, wonderful. And destroy all this. Works like magic. Then I'll get back to my beautiful pen. Okay, so I'm having this. Having it like that. These are my vertices or my points. So we have 75, we have 60, and 45. We have the component F, we have the resultant, and we have the 200 pounds. Okay, so destroyed as well. Alright, so now let us find the resultant as well as the component. We can start with either. Now, in this case, we're not going to use the cosine rule because we don't have two sides. We only have one side. We only have this side. We don't have the other side. But we also have the angle in the middle. But we can't use the cosine rule because it won't work. So given enough angles, or all the angles, and one side, you can use the sine rule to determine the lengths that you want to find, which are the components, and the resultant in this case. So whenever we're using the sine rule, we always have to start with the side that gives you a lot of information. So I'll say sine 45 over 200 is equal to the side that you're looking for with its corresponding angle. So I'll start with the resultant. So the resultant is in that portion. So I'll say sine 75 over false resultant. Then I'll just do some cross multiplication, but don't ever show that. That simply just means that you've cancelled. Just do the cross multiplication in your head. So this will be sine 45 times FR is equal to sine 75 times 200. Then since I'm looking for FR, what I have to do is to divide both sides by sine 45. Even this side, sine 45. That cancels with that. So I have false resultant being equal to, I'll just have to compute this. You just have to compute sine 75 times 200. Then you divide it by sine 45. That will simply give you 273.2050808. Alright, so what I have to do, since I'll be keeping my answers correct to decimal places, I'll just say therefore false resultant is equal to 273.2. The third number is equal to 5. And remember, if the third number is equal to 5, greater than 5, you get a 1, add to that number. So it will be 2, 1. Now remember that one of the components is showing us the units we're supposed to use, which are pounds, LB. So we're just going to put LB. So this is the magnitude of the resultant force. We have answered that portion. So now the next thing we're supposed to do is to find the magnitude of the component of F. If we want to have started with the magnitude of the component of F, then the resultant. Otherwise, the sine rule will work magic for everything we need. So we're going to say sine of the side with the information. So I'll say sine 45 over 200 is equal to the one I'm looking for, which is this side. So that will be sine 60 over F. Then all we have to do is to cross multiply. This will be F times sine 45 is equal to 200 times sine 60. Since we're looking for F, all we have to do is to divide by sine 45. Even this side, sine 45. That cancels with that. So F is equal to, now you do the magic, 200 times sine 60, then divided by sine 45. So you end up having 244. Alright, so we're going to end up having 244.94897 4, 3. So we have to round off to decimal places. I'm just rounding out to decimal places, mind you. If they say round off to whole numbers, just give them whole numbers. Alright, so this will be 244.95 pounds. So this is the magnitude of the component. Alright, so this is basically how you go about finding the magnitude of a component or the resultant, given some information about the resultant and one of the components. Basically, the rules of the procedure or steps to say that we're following are the same steps we followed in the first objective, where we were finding the magnitude of the resultant given two vectors. So remember, always extend your lines, draw parallel lines, then before you even draw the resultant line, find the angles, find the angle in between the two forces or the vectors that are in question. Then after that, draw the resultant line, then pick a side, pick a shape you want, just get one shape to give you everything you need. Then apply either sine or cosine rule. In this case, we're applying the sine rule. And it has worked, which means that the sine rule doesn't necessarily just work for the direction, it can even work for the sides. Alright, thanks for watching. This is Engineer Hussein Wasabi. If you have questions concerning this, you can always reach me on WhatsApp 1077 149 5252. Remember, slow progress is better than no progress. And let us strategize before we become a statistic, and let's try and push for that.